Okay, hope you're having a great time at the conference. I guess we've been seeing some themes and trends in the mobile track connected to, let's say, hybrid technologies, or basically the theme of kind of what we can do, like how can we do more with less code. So I guess my presentation can somewhat, let's say, touch upon that subject. So let me just share my screen. Okay. Yep, I think that works. Okay, so what I wanted to talk about today is basically like a case study of my experience in, let's say, limiting code duplication across web and native mobile app clients. My name is Grzegorz Aperliński, and I'm an engineering manager at Fandom. So a couple of things about me. I'm in the, let's say, tech industry over 10 years now. Started in educational tech. My, let's say, programming career started in front-end development, but I pretty much quickly moved to iOS about the time Swift 1.2 was released. Currently, I'm managing the mobile apps team at Fandom, and privately, I own a Bengal cat and a Rhodesian Ridgeback dog. So basically, that takes up a lot of my time. And when I'm not taking care of my pets, I play board games and try to learn the piano, but it's very kind of difficult. Anyway, moving on to the agenda. So I'll start off talking about the product that my team has been building, D&D Beyond. I'll kind of give you some context around the tech stack that was already there when we started development on the mobile app. I'll explain the technical approach that we've assumed and what we learned from it and what we plan to do next. I'll summarize basically what I'll say in the presentation, and I'll leave time for questions at the end. Obviously, you can write questions in the Q&A chat anytime you want, and I'll revisit them later. Okay, so what's D&D Beyond? Well, basically, to answer that question, I actually need to first start with what D&D is. In case you don't know, D&D, or Dungeons and Dragons, is probably the most popular tabletop RPG system. It's been around since I think 1970s, and now it's in its 5th edition. So a lot of people enjoy playing tabletop RPG games. If you haven't played it, maybe you've seen it played in the Stranger Things TV show. Maybe you're more, let's say, familiar with it. Maybe you've seen a stream of, let's say, like Critical Role or many other YouTube or Twitch streamers that kind of play online. So you can kind of see what it looks like when you actually play D&D. Or maybe you played it yourself with your friends, family, and enjoyed adventures in the high fantasy setting or any other setting that kind of the system allows you to play in. So yeah, so that's D&D. And so here's where D&D Beyond comes in. So D&D Beyond is probably the most comprehensive system to help new and experienced players play D&D. They can create their own characters. They can manage their character sheets, something that may be sometimes quite complicated in terms of the rule set. You can create and track your campaigns, create encounters where you fight monsters and keep track of the players' turns and the dice rolls. And there's also a homebrew system where you basically can create any kind of thing in the world, like a monster or a spell or a weapon, and you can basically customize it into whatever you want to kind of use in your game. And here's basically where my kind of team comes in. It was about like 2 years ago. My team was asked to kind of work on the, let's say, on an extension of perhaps a new mobile app for D&D Beyond. There was already an existing mobile app. It was created by like our friends in Huntsville, Alabama, from the company. It was a small team. They wrote the app in Xamarin, and the functionality that the app had at that point in time was pretty much access to your purchased source books and compendium content, and being able to download that content and read it offline. However, the main point there was that the app was missing the probably the most requested feature, and it was the character sheet. So the character sheet, as you can see, it has loads of information about your character. So like things like your stats, the HP you have, and the spells that are available to you, all that kind of stuff. This is basically automated by the system. You don't have to remember about all the rules, what the modifiers do, how much damage you do. That D&D Beyond basically takes care of it for you. And the mobile app was missing that. So the objective there was to deliver this functionality to a native or potentially other mobile app that can be used offline as well. So we actually decided to start fresh with a new tech stack. The main reason was that let's say we weren't actually familiar with Xamarin and .NET tech stack. As far as I know, support and let's say talent pool for Xamarin is dwindling right now, so we didn't think it was a safe technology to invest in. So instead, we decided to start afresh, and we had two main objectives: basically recreate existing functionality of reading and downloading source books, as well as deliver the much requested character sheet functionality with an offline capability. So to give you more context into where we actually started when we started work on the mobile app, the character sheet, as you've seen it, it's like a front-end app written in React. It pretty much the app, the client, depends on a JavaScript library, like a separate, let's say, module that's called the character rules engine library, and that's where all the rules sit. And it also maintains the state of the character sheet. So pretty much it contains the rules, and it manages changes to the character sheet pretty much on the front end. It's responsible for orchestrating any actions you dispatch into the character sheet and triggering API calls. So it orchestrates and encapsulates the, let's say, the business logic behind the rules of the character sheet. It also distinguishes between hopeful and synchronous actions. So only the latter actually require a response from the API. The former modify the state locally, shoot an API call, and it can either succeed or not, but the local state already changes. And that's important in, let's say, in the context of handling offline use. So that's where what we had at that point in time on the website. And we needed to think about, okay, so how are we going to actually, apart from all the other stuff, how are we actually going to deliver this character sheet functionality in the mobile app? Well, there were a couple of, let's say, potential approaches. First, we could just redo everything natively on iOS and Android. We could also and knowing that the character sheet is a React app, we could look into using React Native maybe to build the character sheet. Perhaps we could use frameworks like Ionic, Cordova that would show the web view to the user with the character sheet. Or maybe there's some other approach where we could run the, let's say, the rules engine or the rules logic within a JavaScript virtual machine, like in runtime environment, and somehow interact with it from the kind of context of native code. So first of all, we decided the title of this presentation would be different if we went for native, because we would be duplicating logic. So we decided that there was too much, let's say, domain-specific knowledge there. There was too much potential maintenance cost in the future to actually duplicate the logic across the clients. So we decided against that. We also decided against React Native. First of all, my team is kind of native first. So we didn't have a lot of experience with React Native, but we also heard stories and had some, let's say, side project experiences with the difficulty to maintain and update React Native libraries. We were kind of worried about the long-term prospects of that approach, so we decided against it. As far for Ionic Cordova, we thought that we would kind of achieve weaker user experience if we were to kind of display a web view for the user. So instead, we looked into the last bit. So actually somehow running the kind of the JavaScript code within some JavaScript virtual machine context and interfacing with that code. To some extent, it's similar to how React Native works, but obviously not that kind of big in terms of scope. So we looked into at two possible ways. Obviously, there were more, but we've kind of shortlisted two. One was to actually run a web view that doesn't actually display, but kind of evaluating JavaScript on that web view. Crazy, but we tried it. And the other one was to actually use a native kind of wrappers for the JavaScript runtime. So JavaScript core on iOS, J2 V8 on Android. We compared the performance of the two, like in terms of performing actual, let's say, some tasks, some calculations, and we found that WebView wasn't as performant as the kind of bare bones JavaScript virtual machine. So we kind of removed that from the list, and we ended up with JavaScript core and J2 V8. So how we actually approached kind of delivering that? Well, we took the character rules engine library, and we've kind of wrapped it with like a client app that pretty much just exposed all the selectors and actions to something that's kind of should be known to React or Redux developers. We exposed them onto a window object. Well, the JavaScript virtual machine, like the JavaScript core and J2 V8, actually don't have a window object. We just created it as an empty object and exposed all the API on it. And we also created like an adapter interface to inject native implementations of some callbacks of some functions. For example, handling API calls. We couldn't basically just use asynchronous JavaScript calls because we would be blocked by calls because of running like local JS. So we had to provide native implementation to handle like get, post, and all the other API requests. We bundle the kind of the client and all the dependencies together into one file with the app and run it locally in the kind of JavaScript virtual machine, and pretty much invoke all the character sheet related logic on that code. And we have also like a callback, like a listener that we invoke, let's say, view redraws when we are informed that there are some state changes coming from the character sheet. And for the kind of the hopeful actions that the character sheet triggers, we actually cache them when you're offline. So kind of the stay idle. And when the user regains connection, we pretty much replay those API calls to kind of sync up the backend with what's happening locally in the character sheet. And when a state changes, we fetch data to display on the UI using selectors that are exposed on the mobile client library. We pass the JavaScript objects that we get into native models, and we use them as kind of the basis to derive the view models and the actual view data for display. So this is just an example. I won't get into much detail here, but how we, for example, create on Android like a kind of a wrapper to like an adapter to handle HTTP requests. So this is like an example of something that will handle a post request. There are functions for kind of callbacks to handle resolving and rejecting, like a JavaScript promise. So basically, we handle this here natively in code. If the API request succeeds, we invoke the resolve function, passing any data that we need, and otherwise rejecting that promise. And we, as I said, we have the window object. We have a namespace there for the character sheet, and we pretty much like inject the native handler under the corresponding, let's say, namespace on the window object. So that acts as an adapter for the rules engine. The rules engine expects an object to sit under that particular namespace, and when it needs to invoke an API call, it invokes that JavaScript code. It comes back to the native implementation. We handle the API request, and we resolve or reject the promise, and the JavaScript code can then interpret that logic further. And like when obtaining data for display, again, we kind of call like a JavaScript method, and we cast it to a given type. In this case, it's just a string, but I'll show you how we actually kind of extended that to build native models. Okay, so apart from just kind of creating the wrapper for the like JavaScript virtual machine and handling the logic, we also extended the approach to generate like native models for the JavaScript objects that we get from the rules engine and from the kind of like the JavaScript layer. And we do that by kind of by taking the TypeScript type declarations from the rules engine and pretty much generating that code with generating native Kotlin and Swift models with a script. Those models are then kind of derived using Moshi on Android, or just the codable protocol on iOS. We ended up generating 400 classes, 100 enums, and 250 selectors in general. So quite a lot of auto-generated code instead of having to kind of write those models ourselves when passing the JavaScript objects. So just to kind of walk you through an example, let's say use case. So let's say I want to get the race of my character, like it can be an elf, gnome, dwarf, anything else. So we start off with the kind of the JavaScript wrapper loaded in memory with the client in memory, passed the correct character ID. It sets up all the data and all the API requests to actually hold the character in memory. Then we call an auto-generated selector. This is like an auto-generated code that we've created with our scripts. So underneath, there's just like a kind of JavaScript string that we invoke. But as you can see, the implementation actually casts it into a race model. Inside the JavaScript wrapper execute, we actually have like invoke the script on the JavaScript context. We cast it to a type. We also do some magic here to kind of limit the number of the fields we actually pass, and I'll speak about it a bit later why we do that. And we get the data. So basically, this is like an example of an auto-generated type. It's quite a big, big type, at least on iOS. The reason being that it's a struct, so it can't inherit as the TypeScript types do. So it basically has all the fields of itself, as well as its parents and its parents, etc. It's quite a big type, right? And that's one of the things I'll also talk about later. But basically, this is the type that we get in native code, and we can access all these fields and let's say use them to build the UI for the user. Okay, so what have we learned from this approach? Well, first of all, the pros. It's great that we could abstract all that logic of handling the character updates. When we started working on D&D Beyond, we weren't that knowledgeable about the rule set of Dungeons and Dragons, so kind of having to learn it as we code would be even more challenging. So it's great that we could just kind of treat it as a black box and just use the API that it exposed for us. All the kind of orchestration of updating the state and invoking the correct API calls, that's all handled by shared JavaScript code, so we don't have that duplication in the clients. And very often, if we wanted to kind of like update the rules, like when a new book comes in or that kind of stuff, we can just regenerate the rules.js file, ship it with the app, and that's all the work that we need to do, because another team handled all the logic for us. So that's great, and it's definitely like been. I suspect doing it natively would take a lot more time. So definitely that was great. But what are the cons? Well, something that we actually hadn't thought about when we kind of did the performance analyses and so on is that converting or passing like JavaScript objects into native types is quite heavy performance-wise. You saw how big the types could be, and they can be even bigger. And if you get like an array of types, and there's like an even larger object that holds some other objects, etc., it can get quite heavy to kind of pass that type from just a simple JavaScript object into an actual strong typed instance in Kotlin or Swift. Another thing that turned out is that when we auto-generated the code, we actually ended up with multiple types that remain unused. Like we have loads of code that kind of we not always need to use in the client app. So again, it kind of complicates stuff. We need to either somehow get rid of them. And the other thing is that the process is kind of sensitive to code changes. So like it's based mostly on regex. So if the team responsible for the rules engine change something in how they kind of define their types, etc., that can break our script. So we need to come back and fix it. And one last thing that we've actually found out on the way is while the rules engine handles a lot of kind of domain-specific logic, there's still quite a lot of, let's say, view model logic that's not handled in the rules engine, but it's handled, let's say, on the web client. So we actually needed to duplicate some logic to get let's say, the raw data that we get from the rules engine to be ready for display in either of the apps. So just to kind of give you an overview of where we kind of ended up, the rules engine sitting in the kind of JavaScript layer, the view model logic that's pretty much a bit duplicated right now. The view related logic, which obviously like native code, so populating views, etc., and that gives you the app. So what next? Well, we basically want to address the cons pretty much. So move away from this, let's say, architecture into this architecture. So kind of taking the shared code a step further to actually handle all the view model preparation logic, also in the kind of shared code, so that when the app invokes anything on the kind of JavaScript layer, it actually gets data ready to be displayed. And so, as I said, we want to kind of put a bit more of the character sheet logic. Obviously, there's other, let's say, functionalities in the mobile apps that are purely native when right now talking about just about the character sheet. So we want to move the logic a bit more into the character sheet. So we pretty much just ask the shared logic for give me the view model for my, let's say, character skills or stuff like that. And it's pretty much ready to be displayed. We also want to generate, like get rid of kind of the auto generation of types. While it sounded great, as I said, there were a lot of types that we actually didn't need to use. And the performance of passing those types wasn't great. So like an example here, if we got an array of items, so items like, sword, kind of a backpack, all the kind of, high fantasy stuff any character has in the inventory, quite a normal list would take us 450 milliseconds to pass into a native view model. When we kind of started to move towards view models and just kind of exposing the data that we actually needed for display, that the performance improved tremendously. So we hope to kind of moving forward into that direction to improve, significantly improve the performance of the and responsiveness of the app. And the other thing that we actually are planning to kind of move towards is being able to update that rules.js source at runtime, like over the air updates. So when like a new rules update gets released, or even like a bug fix gets released to the character sheet, we don't need to like push a new app bundle to the App Store or Google Play to update the rules. We can just kind of push a static file and download it in the app on the next launch, and that would be it. So to summarize what I've been talking about today, I guess, like in my opinion at least, using kind of the JavaScript virtual machine can be an effective and performant tool for reducing client-side code duplication without the baggage of like third-party frameworks, because this is pretty much like a custom-made solution for us that works, and we don't depend on, let's say, the big frameworks that have their own kind of baggage of potential, good things and also issues. So we have a bit more ownership of our direction. As far as code generation goes, it's cool, but it may lead to issues. At least in our case, the kind of let's say, as I said, that sometimes the script would break, or we just kind of, it took us a long, the performance of passing those large types wasn't that great. So maybe it wasn't, let's say, it was okay, but we could do better. And last but not least, like it's essential to kind of understand the use case and dependencies well in order to anticipate potential performance and development issues. And what I'm kind of, it's obvious, right? But in our case, it was, understanding what the rules engine is, what stuff it does and what stuff it doesn't. So we learned over time that the rules engine was great to kind of give you raw data, but we also needed to kind of modify it a bit to get it kind of ready for display. Had we known earlier or understood it earlier, maybe we would have kind of done the gone with a better approach from the get-go. And another thing is that with that passing performance, we actually hadn't thought about that particular performance element that actually impacted the app quite a bit. So we had to kind of come up with allow listing some of the properties and types, so all the properties wouldn't get passed. So it improved performance a bit, but obviously, like going with a dedicated view model type would be much better, in my opinion, at least. Okay, so that's it. Hope that was interesting to you. If you have any questions, feel free to post them in the chat. And if you come up with some questions later on, feel free to contact me at aperlińskifandom.com. Hope you enjoyed the conference, and yeah, see you around. Okay, I don't see a lot of questions or no questions. In that case, I'll sign off. Thanks again, and have a nice rest of the day.